In this video, I'm going to be going over section 3.6 on numerical integration. If I do this right, there's just going to be one video for this section. I'm not going to be spending a whole lot of time on it because most of what you're going to be doing is going to be in Desmos. That's the way that I've set this up. So there are three different methods of using numerical integration. And numerical integration simply means we are reverting back to what you learned in Calc 1 about finding the area under the curve using Riemann sums. So to emphasize that point, we're going to start with the midpoint rule. And I didn't leave myself a lot of space here. I wasn't originally planning on going through the development of the formulas, but I am going to do that for the midpoint rule. So I need to kind of zoom down here to the end where I have some room and talk about the midpoint rule. All right, so you'll remember back from Calc 1 when you developed the idea of finding the area under a curve, we decided to break the area under the curve into a bunch of rectangles. And so that's what I've done here. We have a function. We want to find the area between A and B. And so we create a bunch of little rectangles. And in Calc 1, you would evaluate the height of each rectangle by finding the function value at some point. Okay, so this first rectangle right here, this is the first rectangle. You can find, to evaluate the height of that rectangle, it's simply the function value. That's something you learned in Calc 1. The function value is the height of the rectangle, but it's the function value where the function crosses the top of the rectangle. Now in Calc 1, sometimes that would be the left endpoint, the right endpoint, or you probably learned to do it with the midpoint. And that's what we're going to be doing now, is using the midpoint. So I've tried to draw these so that the midpoint of each rectangle, use a little imagination, the midpoint of each rectangle is touching the curve. All right, that's important. The midpoint of each rectangle is touching the curve. Actually, I'm just going to get rid of this last rectangle. Just pretend this is just one big rectangle. Okay, so go back to green. There we go. So the midpoint of each rectangle is the height of the rectangle. Well, how do we find the midpoint? Well, the midpoint formula is an average. It's the average of the left endpoint and the right endpoint. So you've got, here is the left side of this first rectangle, and here is the right side of the rectangle. The midpoint is the average of those 2 points, right? And so that's what this formula is. x1 plus x2 divided by 2. That's how you find an average. You add two things together and you divide by 2. So we know what the left endpoint is of the first rectangle. It's A. And then if we add h to it, now I'm not using delta x, I'm using h for delta x because that's what we use in Desmos. So h does not mean height. It is the same thing as delta x. It's the width of each rectangle. So the width of this rectangle the width is actually h. But this endpoint right here, the second point is a plus h. Okay, so think about that. For this point is a, we add h to it, so this point is a plus h. So if we wanted to find the midpoint, what we would do is we would have to take a plus h, that would be those 2 points, and divide them by 2. Now, that is my function value. That becomes the height of the rectangle. If I want to find the width of the rectangle, the width of the area of the rectangle is we then multiply the height of the rectangle by h. So remember, this is the height of the rectangle, this is the width of the rectangle, and that gives me the area of the first rectangle. Well, what about the second rectangle? Well, the second rectangle, the left endpoint here is a plus h, the right endpoint is a plus 2h. So to find the area of the second rectangle, we're going to have to take the function value of a plus h plus a plus 2h and divide it by 2. Well, that simplifies to f of 2a plus 3h divided by 2. Then to get the, then we multiply that by h, and we've got the area of the second rectangle. Well, what about the third rectangle? I'm just going to do 3. The third rectangle, the left endpoint is here, the right endpoint is here, so we want to take the average of these two things. So that's going to be a plus 2h plus a plus 3h divided by 2, the function value, which simplifies to f of what, 2a plus 5h divided by 2 times the height is equal to the area. All right, so you can start to see a pattern here evolve, okay? So the first rectangle, the height of the rectangle was, whoops, oh, and I didn't write this as, let me go back and write this, simplify it. This is f of 2a plus h divided by 2 times h, because I didn't add those two together. So here's our 3 rectangles. So if you look at the height of the rectangle, we have 2a plus h divided by 2, 2a plus 3h divided by 2, 2a plus 5h divided by 2. You could probably guess what the next rectangle area is going to be. Yes, it's going to be 2a plus 7h divided by 2, 2a plus 9h divided by 2. So you could go for as many rectangles as you want. Now, in a lot of your problems, it's going to ask you to do h is equal to 6, or h is equal to 8, or h is equal to 10. So we're going to set this up in Desmos to do it. So I'm going to go to Desmos. And so you're going to have access to this. And this Desmos, if you read the top here, it says, to compute area, enter the function and change the values of a, b, and n using the sliders. You can use the sliders, you can just type the number in. Okay. It is currently set up for n equals 8 rectangles. N is the number of rectangles. I leave you to figure out how to change it to 6 or 10. You have to add or subtract terms. So let's just take a look at the midpoint rule, which I have right here. By the way, if this is closed, okay, I have the midpoint rule, trapezoid rule, Simpson's rule. Let's just take a look at the midpoint rule. Here's the rule. Notice the first term, f of a plus 2a plus h divided by 2 plus f of 2a plus 3h divided by 2 plus f of 2a plus 5h, 2a plus 7h, 2a plus 9h, on and it goes. So if you count the number of terms, number of f of whatever, that's how many rectangles you have. So you have 1, 2, 3, 4, 5. Come on. 5, 6, 7, 8. So we're doing 8 rectangles. The other thing I did was I factored out the h. All right, so if we go back to this, each one of these is being multiplied by h, by h, by h. You can simply factor that h out, add up all of these terms, and then multiply by h. And that gives you the formula for Desmos. So let's go back to the first problem. And the first problem, actually I'm doing the second problem. I'm doing the second problem here, is this, which I've already entered into Desmos. So here's how you're going to use Desmos. This is the most important, whoops, sorry. So in Desmos, what you're going to have to do is enter the function in, which I've already done for you. And then you enter your left and right endpoints. A is the left endpoint, so that's 0. So I can just take what happened to my slider? So that's just 0. B is 4, and N is 8 rectangles. So I've got A is 0, B is 4, and again, you can use the slider to slide it to the number that you want, or you can just type the number in. Sometimes it's easier to just type the number in because the slider is very sensitive. N is equal to 8. Then below we have H is equal to B minus A over N. That's just giving me the value of H over here on the right. You don't need to do anything with that. That's calculated automatically. Everything is calculated automatically for you. Now, here's the midpoint rule. It's calculating the midpoint rule. This is the rule that we developed. And so it's giving me the area, the approximate area of 768.1425. That is the midpoint rule. Now, it's also automatically doing the trapezoidal rule. Under the trapezoidal rule, we have 350.4. And the Simpsons rule, there's 3 different rules. And that area is 712.169. So you can see there's a drastic difference between the areas depending on how they're calculated. Some are more accurate than others. And remember, these are all approximations. You use numerical integration when it's just impossible to integrate by any other method, even using tables. All right, so I'm not going to go through an extensive development of the trapezoidal rule or the Simpson rule. You have this Excel spreadsheet to work with. Now, this is set up again for 8 rectangles. If you want to do more rectangles, you have to add on 10, let's say, you would have to add on 2 terms at the end. So with the midpoint rule, you would have to add in a function value of 2a plus 17h divided by 2 plus 2a plus 19h divided by 2. If you want to do 6 rectangles, you would have to eliminate the 2a plus 13h and the 2a plus 15h, so you would only have 6 terms in there. If you get some kind of an error message for A, that means you screwed up the formula. So just thing is exit out of it and open up a new one. Okay, so using the midpoint rule in this problem, so I wrote the midpoint rule out here for 6. You should know how to program this in Desmos. In fact, I would encourage you to open up a blank Desmos and put this in Desmos yourself. Create your own little spreadsheet. And so the midpoint rule, this one has 8, so that's what we were set up for in my spreadsheet. This one has 6, so you could eliminate 2 to do that. The next rule is the trapezoidal rule. Now, the trapezoidal rule is simply another way of finding the area under rectangle. I'm not going to go through the entire development of it. I'll just briefly mention it. Again, the textbook does this for you. It has a complete development of the idea. This is the basic formula. We can factor out an h divided by 2, and then in parentheses you have f of a plus 2 times f of a plus h plus 2 times f of a plus 2h, 2 times f of a plus 3h plus 4h, 5h, 6h. So you can see a pattern developing here, right? So if you had to add on another term, it would be 2 times f of a plus 7h, and another term, 2 times f of a plus 8h. So, and that's what I got to in what I'm saying down here. What it says, same as above, that means this formula plus these extra 2 terms that would be tacked on to the end of this in Desmos. Okay, and so this is the one that I just showed you in Desmos using the trapezoidal rule. So real quick, what basically is the trapezoidal rule? Well, I've got a little bit of space here. The trapezoidal rule, so you've got an area under a curve between A and B. And instead of making rectangles, we're making trapezoids. Now remember what a trapezoid is. A trapezoid looks something like this. It's like a rectangle with one slanted edge. So we go from, let's say, this point here to this point here, and we create, instead of a rectangle, we're creating a trapezoid. And then we trapezoid From there, it's almost like a triangle, really. And then from here to here, we have a trapezoid. From here to here, we have a trapezoid. So the formula is based on the trapezoid. And the formula for finding the area of a trapezoid is you add up the two bases and you multiply by, you take up the bases. So the area of, let me get rid of that. The area of a trapezoid formula is you take base 1 plus base 2 and you divide it by h, and you multiply that by 2. Yeah. That's not the correct formula. Forget that. Anyway. So this is the Desmos formula for it here. And again, if you want to go through the complete development of that, read the textbook. Finally, the Simpson's rule. Okay, here's Simpson's rule. And again, I programmed this into Desmos for you, but you should understand enough that you could program this into Desmos yourself. The rule, of course, the rule is written up here, and I like my version a little bit better. H divided by 3. Okay, and they're using delta x divided by 3. Delta x, remember, is the same as h. I just used h in Desmos. And then in parentheses, you've got f of a plus 4 f of a plus h plus 2 f of a plus 2h, 4 f of a plus 3h, 2 f of a plus 4h, f of a plus 5h, 6h. So you can see there's a pattern. First of all, we always start and end with 1 times the function value. 1 times that, 1 times the last term. And then the terms alternate. There's a 4 here, a 2 here, a 4 here, a 2 here, and it has to end with the 4 and then the 1. So you start with a 1, a 4, and you have to end with a 4 and a 1. So you can only do so many terms. So this is set up for 6 terms. You could not do 7 terms in Simpson's rule because 7 terms would require the next term to be a 2 and then a 1 because these alternate 4, 2, 4, 2, 4, 1. So it has to begin with a 1, 4, end with a 4, 1. And then the function, you have f of a plus 1h, f of a plus 2h, f of a plus 3h, f of a plus 4h, f of a plus 5h, f of a plus 6h. The next term, if we wanted it, would be f of a plus 7h, f of a plus 8h, f of a plus 9h. So there are patterns here. Once you know the patterns, you can do as many terms as you want and set that up in Desmos. Now, what the Simpson's rule is based on is you're taking the area under the curve, and we're creating, of all things, parabolas. So we're approximating the area by creating parabolas. So kind of like, I can't do this very well, but so we got parabolas that are coming around. And again, look at the books. I'm not very good at doing this. So these parabolas are approximating the area under the curve. And so that's the development of Simpson's rule. Okay, that is video number 1. I'll do video number 2 on error, which will also be a very quick video.